Hi guys, today we're going to be talking about algebra, trigonometry, and matrices. How y'all doing today? So we're going to start off with algebra. I'm just going to briefly talk about the key points that you need to know for each topic, and then I'm going to do a CXC past paper question for each topic. So what is a variable? A variable is a symbol that represents different varying values. It can be anything, a letter, a shape, etc. Example, a soca artist is holding a carnival fete. The individual cost of a ticket is $600. Write an expression to evaluate the total cost of tickets purchased. Calculate the cost of buying 15 tickets. Calculate the cost of buying 5 tickets. So for A, write an expression to evaluate the total cost of tickets purchased. Let T represent the number of tickets purchased. So that'll be 600T, 600, which means 600 times T. And B, calculate the cost of buying 15 tickets. So now, you know T represents the number of tickets purchased. So you just have to multiply the 600 by the 15 and you get $9,000. So $9,000 is the cost of buying 15 tickets. Calculate the cost of buying 5 tickets. So now instead of 15, you're going to replace the T with 5. So it's going to be 600 times 5, which is $3,000. So $3,000 is the cost of buying 5 tickets for that carnival fete. Evaluating expressions. Example, 9 take away 8 divided by S equals 9 take away 8 over 4, which is equal to 9 take away 2, which is equal to 7. How do we get that? We just replace, it told us S is equal to 4, so you just replace the S with 4, and 8 divided by 4 equals 2. So that's how we got 9 take away 2 equals 7. Example 2, 4G take away 12 when G is equal to 5. So now we replace G with 5, and we have 4 times 5, which is 20, take away 12, and the answer is 8. Next example, 6 plus 4 over A plus B divided by 3. And they told us A is equal to 4 and B is equal to 3. So now we're going to replace, wherever we see A, we're going to replace it with the number 4. Wherever we see B, we're going to replace it with the number 3. So we have 6 plus 4 divided by 4 plus 3 divided by 3. You know, 4 divided by 4 is 1, so you get 6 plus 1, and 3 divided by 3 is 1 as well, so you get 6 plus 1 plus 1, which is equal to 8. Example 4, 3 plus jk plus k to the power of 3, and when j is equal to 2 and k is equal to 6. So we do the same thing again, replace, wherever we see j, we replace it with the number 2, wherever we see k, we replace it with the number 6. So now we have 3 plus 2 times 6 plus 6 to the power of, sorry, that's supposed to be the power of 3, not the power of 2, so 6 to the power of 3. So that's equal to 3 plus 12 plus 216, and we get 231. Some common identities. So those arrows mean you go from like a squared minus b squared to a plus b, a minus b. So to factorize, we go to the right. So from a squared minus b squared, the identity for that would be a plus b, and in brackets a minus b. A squared plus 2ab plus b squared, that is equal to a plus b in brackets times a plus b. A squared minus 2ab plus b squared equals, in brackets, a minus b times a minus b. A to the power of 3 plus b to the power of 3 is equal to, in brackets, a plus b times a squared minus ab plus b squared. A cubed minus b cubed equals a minus b, and in brackets, a squared plus ab plus b squared. A cubed plus 3a squared b plus 3ab squared plus b cubed equals a plus b to the power of 3. So all cubed. a cubed minus 3a squared b plus 3ab squared minus b cubed equals, in brackets, a minus b cubed. So all of these are just common identities. If you know these, memorize these, know it offhand, understand how you get them, it will help you throughout the exam, because anytime you see a squared minus b squared, anything in that format, for instance, if it's 4 squared minus 2 squared, something like that, the answer will be a plus b and times a minus b. So whatever you have, whatever is a, and whatever is b. So say a was equal to 4, b is equal to 2, you get the answer will be 4 plus 2 times 4 minus 2. 4 plus 2 equals 6. 4 minus 2 equals 2. So then you get 6 times 2. The answer will be 12. So these are some very important identities. And of course there are others, but these are the most common ones. Factorizing. When trying to factor, follow these steps. Factor out any common terms. See if it fits any of the identities, plus any more you may know. And keep going till you can't factor anymore. So just keep factoring until there's no further factoring that you can possibly do. Example 1. 4x squared minus 9 equals 2x squared minus 3 squared. So from the example from the identities that I showed you before, with a squared minus b squared is a perfect example for that. So now you have 2x, which was a, minus 3, which was b, times 2x plus 3. Example 2. W to the power of 4, take away 16. That is equal to w squared. And then all of that squared, take away 4 squared. So that becomes w squared plus 4. And then in brackets, w squared minus 4 from the identities before as well. And you have w squared plus 4, because this could be factorized even further. You get w squared minus 4 is also equal to w plus 2, and in brackets w minus 2. So you see we continue factoring until we can't factor anymore. Example 3. 3u to the power of 4, take away 24u v cubed. So now, what do we have in common there? You see, you could factor out the 3u, because 3u could go into 3u to the power of 4, as well as it can go into 24u v cubed. So if we take out that 3u times u cubed will give you 3u to the power of 4. So that's why we have u cubed in the bracket there. Take away 8v cubed, because 8v cubed times 3u gives you 24uv cubed. And we could go even further, factorizing. 8v cubed is the same as saying 2v to the power of 3. So now we have 3u, and in brackets, u cubed, take away 2v to the power of 3. And we could go even further. So now we have 3u, u minus 2v, and in brackets, u squared plus 2v to the power of 2. And then even further, from using the identities from before, you have 3u, and in brackets, u take away 2v, and then we have u squared plus 2uv plus 4v squared. I know all the letters and numbers might look confusing, but if you really take it step by step, you will get it. Just take your time and factorize. Just see what they have in common, what number could go into both numbers, what if there's a u in both sides of the equation, and go ahead, you could divide by u. So just see what's common, what factor they have in common, and just factorize until you can no longer factorize anymore. Example 4. C cubed take away c squared minus 9c plus 9. So now that is equal to what? Let's see, what do we have in common here? We have c's for 3 of them and we have 9 for 2. So therefore, if you look at c cubed and c squared, we know that c squared could go into both c cubed and c squared. So we could do that one first. So we have c squared outside the bracket, and then we're going to times it by c minus 1. Because if you check it, c squared times c gives you back c cubed. C squared times 1 gives you c squared. So that's how we get c squared times c minus 1. And then you put that minus sign back there from the original question, minus, then minus 9, because we have 9 in common with 9z and 9. So could 9 go into 9z? Yes. How many times? It could go into 1z times. So that's how we have that c there. There's no 1 in front of it, but if there's no number in front of it, it automatically means that it's 1. So 9 times z, or 9 times 1z gives you 9z. And then 9 times negative 1. Negative 9 times negative 1 gives you positive 9. Then we could go even further. You see that we have this c minus 1 in common in both of them. So therefore we could do c squared minus 9 times c minus 1. And that c squared minus 9 could be broken down even further. You get c minus 3 times c plus 3 times c minus 1. Inequalities. So this first one is greater than, second one less than, third one greater than or equal to, then less than or equal to. An easy way to remember it, if you use your right hand and put it on your hip, make it in the shape of that sign, right hand is greater than, left hand is less than, and left and less starts with the same letter L. So that's an easy way to remember. They both start with the same letter L. So less than, left hand. Right hand, greater than. These things do not affect the direction of the inequality. Add or subtract a number from both sides. That doesn't change the direction of the inequality. Multiply or divide both sides by a positive number. Keyword positive number there. That doesn't change the direction of the signs. Simplify a side. That doesn't change the direction of the sign. But these things do change the direction of the inequality. So the less than becomes a greater than. For example, if you multiply or divide both sides by a negative number, then the sign switches. And then I'm going to show you examples later on. Swapping left and right hand sides. So if you swap from left to right, like the whole equation from the left hand side, it carries across to the other side, that's going to change the direction of the signs. We do some examples. Example 1. Negative 5x is greater than 20. So that is equal to x is less than negative 4. How did we get that? Negative 5x, in order to get 1x, you have to figure out what do we do to that negative 5x to get 1x. So we know if you divide negative 5x by negative 5, you get 1x. And therefore, if you do that on this side, that means you have to do it on the other side of the inequality as well. So you get 20 divided by negative 5, which is negative 4. And from the rules that we said before, if you divide by a negative number, that changes the sign. So it becomes less than instead of greater than. So you get x is less than negative 4. Example 2. 5x is greater than 20. So we do the same thing. We divide by, this time we divide by positive 5. So you get 5x divided by 5 gives you x. 20 divided by 5 gives you 4. But if you notice, the sign did not change this time. And why didn't it change? It's because we divided by a positive number. So it's only when you divide by a negative number is when the sign changes. Example 3. 6 plus 4x is greater than 3. So that is equal to 4x is greater than 3 minus 6. How do we get that? Because the 6 is positive, we have to, and you want to put all the like terms together, we have to minus 6 on the left hand side of the inequality. Then therefore if we minus it on the left hand side, we're going to get 6 minus 6 plus 4x, which becomes 0 plus 4x, which is just simply 4x, because you know anything plus 0 gives you the original answer. So 1 plus 0 gives you 1, 2 plus 0 gives you 2, so 4x plus 0 will give you 4x. And then because we took away 6 on the left hand side, we have to do it on the right hand side as well, so it becomes 3 minus 6. So now we have 4x is greater than 3 minus 6, and from 3 minus 6, we know that is negative 3, so we have 4x is greater than negative 3. And now, in order to get 1x, we need to divide by 4 on both sides. So we get x is greater than negative 3 over 4. Treasured Viking, which part looks confusing? I'm now saying which part you didn't understand. Alright, while I wait for Treasured Viking to say which part looks confusing, let's go on to the past paper question. So we're going to look at the CSEC January 2008 paper 2, question 2 problem. Solve the inequality. Okay. I'm glad you understand now. Solve the inequality 3 minus 2x is less than 7. So 3 minus 2x is less than 7. We want to get like terms together. So we're going to keep we'll keep the x on one side and just the numbers without the variables on the other side. Okay, so now if you want to get that 7 with the 3, you're going to minus 7 on the right hand side. Therefore we have to minus 7 on the left hand side. So we have now 3 minus 7 is less than 2x. How do we get 2x? It's negative 2x on the left hand side, so therefore we have to add 2x on the left hand side, because negative 2x plus 2x gives you 0. Therefore we need to add it on the right hand side as well. So now we have, because we already moved the 7, now we have 0 plus 2x, so that becomes 2x. So now we have 3 minus 7 is less than 2x. 3 minus 7 gives you negative 4, which is less than 2x. And now we want to get 1x. So if we divide 2x by 2, we get x. And also if we divide a negative 4 by 2, we get negative 2. So now the answer is negative 2 is less than x. If x is a whole number, determine the smallest value that satisfies the inequality in question A1 above. So the answer was negative 2 is less than x. We know that whole numbers are a number it starts from 0 and then it goes 1, 2, 3. Those are all whole numbers, or negative numbers are not whole numbers. So because we know that whole number starts from 0, the smallest whole number that will satisfy the inequality is 0. X is equal to 0. Factorize completely. X squared minus xy equals x times x minus y. How did we get that? Because x times x gives you x squared negative. And now how do we get a negative xy? X times negative y gives you negative xy. A squared minus 1 that is equal to, from the identities that I showed you before, that is equal to a minus 1 times a plus 1. If you were to actually work that out, you will see that you get back to the original answer. We could actually do it quickly now. A times a gives you a squared. Then a times 1 gives you a. Then you go negative 1 times a gives you negative a. And negative 1 times 1 gives you negative 1. And now when you solve all of that, you get a squared plus a minus 1. And now you know negative a plus a is 0. So that's how we get a squared minus 1. Now we have 2p minus 2q minus p squared plus pq. Now let's see, what do we have in common? I see we have 1, 2, 3 of them with p's and only 2 with q's. So let's see, pull out the p. So now we have, if we get p times 2 minus p minus q times 2 minus p. And how we got that? P times 2 gives you 2p minus p times p, which is p squared, so minus p squared minus 2q plus pq. And now the 2 minus p, we have that twice, so therefore we can now write p minus, so that's how you know your answer is correct, when you see you have the same exact one twice. So now we have p minus q times 2 minus p. Let me know if I'm going too fast for you all, if you're having any problems understanding. Part C. The table below shows the types of cakes available at a bakery, the cost of each cake, and the number of cakes sold for a given day. So sponge cake is K plus $5. The number of cakes sold is 2 cakes. Chocolate cake is K dollars, and 10 cakes were sold. Fruit cake was $2K, and 4 cakes were sold. Write an expression in terms of K for the amount of money collected from the sale of sponge cakes for the day. So we have, they want to know for sponge cakes, and sponge cakes was K plus 5. And they sold 2 sponge cakes, so that is 2 times K plus $5, which is equal to, so you have to multiply that 2 by everything in the brackets. Now 2 times K gives you 2K plus 2 times 5 gives you 10. So 2K plus 10. 2. Write an expression in terms of K for the total amount of money collected. So for total, that means for all the cakes. So for the sponge cake was 2 times K plus 5 plus the chocolate plus the fruit cake. So that's plus 10 times K plus 4 times 2K, which is equal to 2K plus 10 plus 10K plus 4 times 2K, which is 8K. When you add all the numbers together and all the variables, we get 20K plus 10. And the total amount of money collected at the bakery for the day was $140. Determine the value of K. So now we have 20K plus 10 equals 140. Because 20K plus 10 represents the total amount of money that was collected, and they told you the total amount of money that was collected was 140. So that's why we put them equal to each other. And now put the like terms together. So we leave 20K on the left hand side, and we want to carry that 10 across to by the 140. How do we do that? We take it away, because it's positive 10, that means we have to subtract 10 on the left hand side, therefore we have to subtract 10 on the right hand side as well. And now we have 20K equals 130, and if you want to get 1K, we have to divide by 20 on both sides. So now K is equal to 130 divided by 20, which is equal to $6.50. Now we're going to move on to trigonometry. Trig functions. Right triangle definition. For this definition, we assume that 2, P is less than Q. Sorry about that, I'm not sure why it came out this way. Or 0 degrees is less than Q, which is less than 90 degrees. So if we look at this right angle triangle, we see the slant is the hypotenuse, and the side that's opposite, the angle is called opposite, and the side that's right next to it is called adjacent. The sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. Tan theta is equal to opposite over adjacent. Sec theta is equal to hypotenuse over opposite. Sec theta is equal to hypotenuse over adjacent. And cot theta equals adjacent over hypotenuse. These are just some important trig functions that you should remember, especially sine, cos, and tan. The domain is all the values of theta that can be plugged into the function. Sine theta can be any angle. Cos theta can be any angle as well. Tan theta cannot be equal to n plus 1/2 times pi, and that n cannot be equal to could be equal to 0, plus or minus 1, plus or negative 2, and so forth. It could also be like plus or minus 3, etc., etc. SOHCAHTOA, nice, yes, good job. That's also how, that's a good way to remember it. That's how I remembered it as well. That's in school. SOHCAHTOA. Yes. CSEC theta is not equal to n times pi. N is equal to 0, positive or negative 1, positive or negative 2, positive or negative 3, and so forth. Sec theta is not equal to n plus 1/2 times pi. N is equal to 0, positive or negative 1, positive or negative 2, so forth. Cot theta is not equal to n times pi. N is equal to 0, positive or negative 1, positive or negative 2. These are just some things to help you on when you're doing like domains, just stuff you can learn off. The range is all possible values to get out of the function. Negative 1 is less than or equal to sine theta, which is less than or equal to 1. Negative 1 is less than or equal to cos theta, which is less than or equal to 1. Negative theta is less than tan theta, which is less than theta. Sec theta is greater than or equal to 1, and sec theta is less than or equal to negative 1. Sec theta is greater than or equal to 1, and sec theta is less than or equal to negative 1. Negative 8 is less than cot theta, which is less than infinity. Oh my gosh, I just said negative 8. I meant negative infinity is less than cot theta, which is less than infinity. Tangent and cotangent identities. Tan theta is equal to sine theta over cos theta. Cot theta is equal to cos theta over sine theta. Reciprocal identities. Sec theta is equal to 1 over sine theta. Sine theta is equal to 1 over sec theta. Sec theta is equal to 1 over cos theta. Cos theta is equal to 1 over sec theta. Cot theta is equal to 1 over tan theta. Tan theta is equal to 1 over cot theta. Pythagorean identities. Sine squared theta plus cos squared theta equals 1. Tan squared theta plus 1 equals sec squared theta. 1 plus cot squared theta equals c-sec squared theta. Even or odd formulas. Sine times negative theta is equal to negative sine theta. Cos times negative theta equals cos theta. Tan times negative theta equals negative tan theta. C-sec times negative theta equals c-sec theta. Negative c-sec theta. Sec times negative theta equals sec theta. Cot times negative theta equals negative cot theta. So these are just important trig functions that you should remember. I know it's a lot, but they usually also give you on the formula sheet for the exam, so it's not like you really have to memorize it, but if you know it offhand, it helps. So you don't have to be going back and forth in the exam. The law of sines, or sine rule, is very useful for solving triangles. This is the rule here. A over sine A is equal to B over sine B, which is equal to C over sine C. A, B, and C are sides. Capital A, capital B, and capital C are angles. Side A faces angle A, side B faces angle B, and side C faces angle C. When we divide side by the sine of angle A, it is equal to side B divided by the sine of angle B, and it's also equal to side C divided by the sine of angle C. Loopsy phantom, I'm glad I could help. No, there's no pause in the video. Stacy, what's confusing you? What I've done so far is just state all the functions, but it's just stuff that you need to know and memorize. I'm going to give you examples later on. Trig functions continuation. The law of cosine or cosine rule says c squared is equal to a squared plus b squared minus 2ab cos angle C. A, B, and C are sides, just like in the triangle before. So that's a common A, common B, and common C. Those are the sides. And the capital C is the angle opposite side C. Komal, I'm glad you're understanding. That's good to know. Glad I could be helpful. Yes, but you could also use the sine rule to find the side as well. If you have, say for instance, if you have two sides and one angle, you could find the angle using the sine rule. And if you have two angles on one side, you could also use the sine rule to find the other side. Yes, Stacey, I know it's a lot. But just try to take as much as you can. Or you could also rewatch the video after and take notes. Because I know it's probably going through quickly now, but you could take your time and pause later on, like rewatch it and pause whenever you get a chance. And take notes, go through the examples, make sure you understand. Alright, so we're going to look at May-June 2019, paper 2, question 9b. The diagram below shows a quadrilateral PQRS where PQ and SR are parallel. SQ equals 8 centimeters. So now they give you angle SPQ equals 90 degrees, angle SQR equals 82 degrees, and angle QSR equals 30 degrees. And they ask you to find, they ask you to find the length of PS, the length PQ, and the area of PQRS. So alright, let's go to the length PS. Length PS is equal, so length PS divided by 8. How do we get 8? Because we're going to use the sine rule. Let's see. Length PS is right over here by the right angle. Do you see it? And then length 8 centimeters is the hypotenuse. So what are we going to use there? We have to use sine because opposite over hypotenuse, which is equal to sine 30 because the angle is 30 degrees. Length of PS equals 8 sine 30, which is equal to 4 centimeters. So you put in your calculator. That's how we got the 4 centimeters. And length of PQ divided by 8 equals sine 60. Length of PQ equals 8 sine 60. How do we get the 8 sine 60? We cross multiplied. So that becomes length of PQ over 8 is equal to sine 60 over 1. And when you cross multiply, you get length of PQ equals 8 sine 60, which is equal to 6.9 centimeters. Using sine rule. So now we use the sine rule to, first they want us to find the area, but in order to find the area, we need to find the other side because we need to find the sine SR because we don't have the length of that side as yet. So in order to find the length of SR, we use the sine rule first, and now we have SR over sine 82 is equal to 8 over sine 68. When you cross multiply, you get SR sine 68 equals 8 sine 82. And now, in order to get SR, we have to divide by sine 68 on the left-hand side. And therefore, we also have to divide by sine 68 on the right-hand side. So we get SR equals 8 sine 82 divided by sine 68. 8 sine 82 is equal to 7.9. And sine 68 equals 0.927, and 7.9 divided by 0.927 is equal to 8.5 centimeters. So that's the first part. So that's we found SR. So now we need to find the area. Which one we? Right, so now the area of the trapezium is equal to H times A plus B divided by 2. That's just a formula to find the area of the trapezium. And that will be, so now we're using all the lengths that we have from before, which is the height was 4 times 8.5 plus 6.9 divided by 2. And when you work that out, you calculate it, you add those values and multiply by 4, then divide by 2, you get 30.8 centimeters squared. So it's really, we just need to take our time, break it down, think about what we need, if we have all the lengths that we need, if we have all the angles that we need that they're looking for. And then also it's very important, I know we're doing tricks right now, but it's also important that you can see we still need to know the area of the trapezium. So it's good to know all the areas, area of rectangle, triangle, square, circle, because all of that helps for trigonometry as well. If you realize in math, like all the topics are connected. So you need to know everything from the beginning all the way to the end. Even in terms of fractions and decimals, you could see fractions and decimals in trigs, as for instance, this question right here, we had 8.5, that's a decimal. So you really need to know, just keep practicing all the topics in math in general, and that helps with everything. Math is all about practice, practice, practice. And the last topic we're going to do is matrices. What is a matrix? A matrix is an array of numbers. It is usually shown by a capital letter such as A, B, etc. Each entry or element is shown by a common letter with a subscript showing row and column. So in this example here, we have -3, 6, 5, -1, 8, and 0. This matrix has 2 rows and 2 columns, known as a 3 times 2 matrix. And we have 2, 7, 5, 2, 8, 1. This matrix has 2 rows and 3 columns, known as a 2 by 3 matrix. Don't worry about that type equation here, that's not supposed to be there. And this picture to the right here shows an example of the matrix. It shows you A, the capital A, and then it shows you all the common A's with the subscript that represents what row it's in and what column is in. For instance, see where that arrow points and says second row. If you look at that last A there, you have A, 2, and that 2 represents the second row, 2 and n, because it's the nth column. If you look at A2, 3, it shows you the 2 represents the second row and the 3 represents the third column. To add matrices, add the numbers in the matching positions. Example, so we have 6, 1, -2, 4, plus 4, 3, -2, 1. So that's equal to, so if you see, you see the 6 and the 4 in the same positions, they're in the matching position. So you add 6 plus 4, you get 10. You add 1 plus -2, that gives you -1. -2 plus 3 gives you +1. 4 plus 1 gives you 5. Note, the second matrix must be the same size so it must be the same rows, same number of rows, and same number of columns. They must match in size in order for you to add the 2 matrices. Negative matrices. So -4, 3, -2, 1. So if that's basically, if you think of brackets, if you have a negative sign outside of a bracket, you have to multiply everything inside that bracket by that negative sign. So it's the same thing with matrices. So you're going to say negative, and there's no number in front of the matrices. So just as everything else, if there's no number, you assume that it's 1. So that becomes like saying -1 times 4, which is -4. -1 times -2 gives you +2. -1 times 3 gives you -3. -1 times 1 gives you -1. Subtracting matrices. To subtract matrices, subtract the numbers in the matching position. So same as addition, you look for the numbers in the matching positions. So this becomes 6, take away 4 gives you 2. 1 minus -2, which becomes 1 plus 2, which is equal to 3. -2 minus 3 equals -5. 4 minus 1 equals -3. Note, the second matrix must be the same size, so the rows and columns must match in size. So same as addition, must have the same number of rows and columns. Subtracting is actually defined as the addition of a negative matrix. So A plus minus B. And the negative matrix is what we did in the previous slide, what we looked at in the previous slide. Multiply by a constant. We can multiply a matrix by a constant. The value 3 in this case. So you see 3 is a constant in this case, so 3 times, and the matrix 4, -2, 3, 1. So you have to multiply that 3. It works just like with brackets. So that's 3 times everything in the matrix. So 3 times 4 gives you 12. 3 times -6. -2, sorry, gives you -6. 3 times 3 gives you 9. 3 times 1 gives you 3. Note, we call the constant a scalar. So this is scalar multiplication. Multiplying a matrix by another matrix. We use a dot product of rows and columns while multiplying a matrix by another matrix. Example, 1, 2, 3, 4, 5, 6 times the other matrix, which is 7, 8, 9, 10, 11, 12. So, how do we do that? Let's see. So you multiply, as it said, we multiply the row by the column. So you're going to multiply the first row by the first column, which is 1 times 7 plus 2 times 9 plus 3 times 11. So that will go into A1, 1. Then we do the same first row by the second column in the matrix from the second matrix. So now we have 1 times 8 plus 2 times 10 plus 3 times 12. Then we do the same thing for the second row. Multiply the second row by the first column, then multiply the second row by the second column. So now we have 4 times 7 plus 5 times 9 plus 6 times 11. Then 4 times 8 plus 5 times 10 plus 6 times 12. And when we do all the multiplications and then add all of the numbers, we get 58, 64, 139, 154. Are we doing okay so far? Multiplying a matrix by another matrix. Note, the number of columns in the first matrix must equal the number of rows in the second matrix. The result will have the same number of rows of the first matrix and the same number of columns of the second matrix. So in this example, the example we just did previously when we got 58, 64, 139, 154, the first matrix has 3 columns and the second matrix has 3 rows. The first matrix has 2 rows, therefore the answer has 2 rows. Also, the second matrix has 2 columns, therefore the answer has 2 columns. So these are important things to take note of, so then when you do it, you know if your answer is correct or not, if you realize that they have the same number of rows as the first matrix and columns as the second matrix. Identity matrix. The identity matrix is the matrix equivalent for the number 1. I equals 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is an example of a 3 by 3 identity matrix. Identity matrix is a square matrix. It has the same number of rows and columns. That's what it means by a square matrix. It has the same number of rows and columns. It can be large or small. 2 times 2, like a 2 by 2 matrix, 100 by 100 matrix. Could be a 32 by 32 matrix. It has 1s in the main diagonal and 0s everywhere else. Its symbol is the capital letter I. It is a special matrix because when we multiply by it, the original is unchanged. So A times I equals A. Just think of the number 1. When you multiply anything by the number 1, you get the original number. It doesn't change. Like 5 times 1 gives you 5. 200 times 1 gives you 200. Identity matrix works the same way. So A times I gives you A. If you multiply B times I, that will be equal to B. So you get the original matrix. It doesn't change. Order matters in multiplication of matrices. AB is not equal to BA. Example, 1, 2, 3, 4 times the matrix 2, 0, 1, 2. So we do the same thing as before, row by column. So we get 1 times 2 plus 2 times 1 then 1 times 0 plus 2 times 2, and 3 times 2 plus 4 times 1, then 3 times 0 plus 4 times 2. When you work that out, we get 4, 4, 10, 8. So that was A times B, okay? Now if we look at B times A, we have 2 times 1 plus 0 times 3, then 2 times 2 plus 0 times 4, 1 times 1 plus 2 times 3, 1 times 2 plus 2 times 4. When you work that out, we get 2, 4, 7, 10. You see, we got two different matrices for those answers. So the first one, when we did A times B, we got 4, 4, 10, 8. When we did B times A, we got 2, 4, 7, 10. So you see, AB is not equal to BA. When we change the order of the matrix in multiplication, the answer is usually different. See that word there? Usually. So it's not always different. It's usually different. It will be the same if we multiply by an identity matrix. So that's the only time it will be the same. Remember, the identity matrix works as 1, the number 1. So if you multiply anything by that number, even if we did before, you get the same matrix. It's unchanged. Janaya, what are you confused about? When we do in multiplication, we do row by column. So you do the first row by the first column, and that goes for the first, so that goes by A 1 1, and then you do the first row by the second column. So the first row by the first column, first row by the second column, and then you do the same thing with the second row. The second row by the first column, and then the second row by the second column. And you just multiply each number, and then you add them. What is confusing you? Dividing matrices. A divided by B is equal to A times 1 over B. Oh, you're welcome. Which is equal to A times B to the power of negative 1, where B to the power of negative 1 is the inverse of B. So we don't divide, instead we multiply by the inverse. Note, the inverse of B is B to the power of negative 1 only when B times B to the power of negative 1 is equal to B to the power of negative 1 times B, which is equal to I. Sometimes there is no inverse. Oh, that's good, Janaya. Glad you understand now. So you see, that's important. Sometimes there is no inverse. So if you work it out and you realize it's not equal to I, don't panic. The answer could still be correct because sometimes there is no inverse. So 2 times 2, 2 by 2 matrix, A, B, C, D to the power of negative 1 is equal to 1 over AD minus BC times the matrix D minus B negative C A. So how did we get that? So we swap the A and D. If you realize they changed, the A and D changed positions. So we swap the A and D and we put negatives in front of B and C, and then we divide by the determinant. The determinant is AD minus BC. What does AD minus BC mean? It means A times D minus B times C. If the determinant is 0, there is no inverse. Such matrix is called a singular. So you see, it is possible that there is no inverse. And what do we call that? We call that matrix a singular. So this is just the formula that we use, 1 over AD minus BC and times the matrix D minus negative B, negative CA. So just remember, it's as you swap in A and D and put a negative sign in front of B and C. Example 4726. The inverse of that is equal to 1, using the formula from above, 1 over the determinant, which is AD minus BC. So we just replace AD minus BC with the actual numbers. So we get 4 times 6 minus 7 times 2. And all of that is times 6. We're going to swap A and D. I'm going to put negatives in front of B and C. So now we have 6, negative 7, negative 2, 4. So that is equal to, when we work out 4 times 6 minus 7 times 2, we get 1 over 10. And that times the same 6, negative 7, negative 2, 4. When we multiply the 1 over 10 by everything in the matrix, we get 0.6, negative 0.7, negative 0.2, and 0.4. To see if it is correct, multiply the matrix by the inverse. Because remember, when you multiply the matrix by the inverse, you're supposed to get the identity matrix. That's the only way you know if it's correct or not. So let's see. The original matrix was 4, 7, 2, 6, and the inverse was 0 times 0.6, negative 0.7, negative 0.2, and 0.4. So when we multiply those two by each other, the answer was 1, 0, 0, 1, and you know that's the identity matrix because we have 1s in the main diagonal and everything else is 0, so therefore we know our answer is correct. When you have a chance, you could just actually work it out step by step and see if you make sure you get that answer 1, 0, 0, 1. I didn't show you all the steps, one because we've done it previously already. So, but as you have time, you could pause the video and try it on your own. Transposing. To transpose a matrix, swap the rows and columns. We put a T in the top right hand corner to mean transpose. So 1, 2, 3, 4, negative 5, 6. You see, we just swap the rows and columns. So now we have 1, 4, 2, negative 5, 3, 6. So it's the same exact numbers. We just literally just swap the rows and the columns. So instead of 1, 2, 3 as the first row, it's going to be the first column. Alright, now we're on to the May-June 2019 paper 2, question 10A. So first part, find the matrix product. So the matrix product of negative 1, 3, 4, H. So that times K5. That is equal to negative 1 times K. And then we have 3 times 5, because remember row by column. Then 4 times K. Then H times 5. So from that, after we work out the multiplications, we get negative K plus 15 and 4K plus 5H. Part B. Hence, find the values of H and K that satisfy the matrix equation. So negative 1, 3, 4, H by K5 is equal to 0, 0. So we want to solve for K and H when we put that equation. So 1 is equal to 0, 0. So now we have negative K from the calculation from part A. We got negative K plus 15, 4K plus 5H. So therefore negative K plus 15 is equal to 0. And 4K plus 5H is equal to 0. So from the negative K plus 15 equals 0, we want to get the K by itself. So in order to do that, we need to move that positive 15. In order to move it, we have to subtract 15 on both sides. So we get negative K equals negative 15. And if you want to know for K, so we know negative K is also the same as negative 1K. So if you want to get positive K, we need to divide by negative 1 on both sides. So we have negative K divided by negative 1 is equal to K. Negative 15 divided by negative 1 is equal to 15. Therefore, K is equal to 15. 4K plus 5H is equal to 0. So now we know that K is equal to 15. So we just replace the K with 15. So now we have 4 times 15 plus 5H equals 0. 4 times 15 is equal to 60. So we have 60 plus 5H is equal to 0. 5h now is equal to negative 60. How we got that? We need to move the 60 from the left hand side to the right hand side, and seeing that it's positive, we need to subtract it on both sides. So we get 5h is equal to negative 60. Therefore, h is equal to negative 12 because we have to divide by 5 on both sides. 5h divided by 5 is positive h, and negative 60 divided by 5 is negative 12. Which topic again? The entire matrices, you mean? Oh, like which part? Because I'm not sure exactly which part you're talking about. We covered a lot in matrices. I'm not sure if it's the multiplication, division, addition, which part. Using a matrix method, solve the simultaneous equations. Two x or the same one. Okay, I'll go back. Let me go back. I'll go back and start from the beginning of this question for Janaya. So it said find the matrix product, and they gave us, this was a question, they gave us negative 1, 3, and 4h times, and next matrix k5. Like that was given in the question. That was the question. So now we do row by column from what I said previously. So the row is negative 1, 3. We're going to times that by the k5. So you have negative 1 times k plus 3 times 5. I think what may have confused you, because I don't have the plus sign there. I should have put a plus sign right there. So it's supposed to be negative 1 times k plus 3 times 5. Maybe that's what's confusing. And when you get that, now you have negative k, that's equal to negative k plus 15. Then you have 4 times k plus h times 5. You get 4k plus 5h. And then the second part now is part B. They said, hence, find the values of h and k that satisfies the matrix equation. So they gave you the same exact matrix product from before. So it's negative 1, 3, 4h times k, 5. And they gave you that is equal to 0, 0. So this part, that's the part that they gave you in the question. So now we know that negative 1, 3, 4h times k over 5, that is equal to negative k plus 15, 4k plus 5h, because we solved that in part A. So now we're going to use that negative k plus 15, 4k plus 5h is equal to 0, 0. So we know that negative k plus 15, if we look at that first row, is equal to 0. So how do we solve for k now? We need to get the k on one side and the number on the other side. So the 15 is positive 15, so we need to carry it on the other side. When it crosses, the equal sign becomes negative 15. So we have negative k is equal to negative 15. Because it's negative k and there's no number in front of it, we know that it means negative 1k. Because negative 1k is the same as saying negative k. So in order to get positive k now, and negative divided by negative gives you a positive number. So negative k divided by negative 1 gives you positive k. Negative 15 divided by negative 1 gives you positive 15. 4k plus 5h equals 0. So because we already know that k is equal to 15, we're just going to replace the k now with 15. So we have 4 times 15 plus 5h equals 0. 4 times 15 is equal to 60. 60 plus 5h is equal to 0. So now we want to get the like terms together. So we need to subtract 60 from both sides. So that becomes 60 take away 60, which is 0, plus 5h. So that's how we got 5h on one side. And then 0 minus 60 gives you negative 60. So that's how we got 5h minus equals negative 60. Now in order to get h, 1h, we need to divide by 5 on both sides. So that becomes 5h divided by 5, you get h, and negative 60 divided by 5, you get negative 12. So the answer is h is equal to negative 12. I hope that brought some sort of clarification to you. Are you still confused, or do you understand a little better now? So the second part, using the matrix method, solve the simultaneous equations 2x plus 3y equals 5. Negative 5x plus y equals 13. So we have 2, 3, negative 5, 1 times xy. So this is just writing the same simultaneous equations that they gave you. We're writing it in matrix form right now. So 2, 3, negative 5, 1, xy is equal to 5, 13. Okay, I'm happy to hear that it helped a little bit. When you have time, just go through it on your own and just try to break it down. Maybe when you write it down, you might see it a little clearer. First, so for this one now, first calculate the 2, 3, negative 5, 1, the inverse of that. So that is equal to, and why do we calculate the inverse of it? Because remember, there is no division in matrices. Dividing matrices means multiplying by 1 over, by multiplying by the inverse, basically. And because we have matrix 2, 3, negative 5, 1 times xy, if you want to get the xy by itself, because you're trying to solve for x and y, so you're trying to get the like terms together, basically. So if you want to get the xy by itself, that means we need to divide by the matrix 2, 3, negative 5, 1. But because there's no division in matrices, we need to multiply by the inverse of that matrix. So that's why we have to solve the inverse of 2, 3, negative 5, 1. So that's what we're doing right now. So the inverse of 2, 3, negative 5, 1 is equal to 1 over the determinant, which is 1 over 2 minus 15. How did we get that? Because remember, it's AD minus BC. So AD is 2 times 1, that's how we got 2, minus BC, which is 3 times negative 5, which is negative 15. So now we have 1 over 2 minus 15. And then we need to multiply that by the matrix. Remember, we need to swap A and D, and then the negatives of B and C. Seeing that C is already in negative 5, and a negative times a negative gives us a positive, that becomes positive 5. And the 3 will become negative 3. So now, when we solve 2 minus 15, we get 17 at the bottom there. So now we have 1 over 17 times 1, negative 3, 5, 2. And when we times it, so 1 times 1 over 17, you get 1 over 17. Negative 3 times 1 over 17, you get negative 3 over 17. 5 times 1 over 17, you get 5 over 17. 2 times 1 over 17, you get 2 over 17. Therefore, xy is equal to 1 over 17, negative 3 over 17, 5 over 17, 2 over 17, times 5 over 13. How did we get that? So remember when we found the inverse, that means you have to multiply by the inverse on both sides. Remember, whatever you do to one side, you have to do it to the other side. So now, that's why we're going to times the right-hand side, so the other side of the equal sign, by the inverse that we got. So that's why we're timesing it by 5 over 13. So now when you multiply each of those, we have now 5 times 1 over 17 plus 13 times negative 3 over 17. And then 5 times 5 over 17 plus 13 times 2 over 17. When we solve that, we get 5 over 17 minus 39 over 17, and then 25 over 17 plus 26 over 17. When you subtract on top, we get So 5 take away 39, we get negative 34 over 17. 25 plus 26, we get 51 over 17. And that could be broken down even further. Negative 34 divided by 17 is negative 2. And 51 divided by 17 is 3. Therefore, x is equal to negative 2 and y is equal to 3. I'm glad I could help Kamal. Glad it's easy. I tried to break it down as much as possible. So I'm glad it was very helpful. And that's it. Thanks for watching. Any questions before I go? Or was that clear enough? I know it's just an hour for 3 different topics, so it's a lot of information, short space of time. But the good thing is it's online now, so you could rewatch it, take your time, pause wherever need be, take notes, try all the examples on your own, try the questions all over again, then look back to see if the answer is correct. I think looks like there are no questions, so thank you for watching and have a good day. Enjoy the rest of your night. You're welcome. Sorry, good thing I looked down before. Yes, I'm sure I'll be having more sessions, but I'm not sure exactly when. Just look out for it. I'm not sure what date and time. You're welcome. Have a good night, guys. Bye.